Hello everyone. Today we'll discuss limits of functions. So, why it is necessary to study limit of a function? Because it is the gateway to calculus and the key to understanding how function behaves. It changes and approaches specific values. It helps to study the behavior of functions. It helps in understanding continuity of the function and to understanding the derivative of the functions, the definite integrals. So it is the foundation of the calculus and many more advanced areas of mathematics. So now come to the definition of the limit. So let fx be a function defined on some interval around a point a, except possibly at a itself. So we say limit of fx as x tends to a is equal to L. So before going to the limit, first function must be defined. So at a, if we have to find the limit, so function at a may or may not be defined, but it must be defined on some interval around a point a. So this function must be defined. Your function must be defined. Your function fx, it must be defined at some interval around a. But at a, it may or may not be defined. So in that case, we write limit of fx as x tends to a is equal to L. So how it is defined? So for every epsilon greater than 0, there exists a delta greater than 0 such that 0 less than mod of x minus a less than delta implies fx minus L mod less than epsilon. So what does it mean? What does it mean? It the limit f of x equal to L as x tends to a, that is when x approaches to a, when this x approaches to a, your fx approaches to L. In other words, we can say the difference between fx and L. I mean, fx approaches to L means what? The difference between fx minus L is less than epsilon. Epsilon is very, very small and it is positive number greater than 0, but it is very, very small. So the difference between fx minus L is very, very small whenever your difference between x and a is very small. That means when x approaches to a, your fx approaches to L. When x approaches to a, fx approaches to L. So in that case, we write limit of fx is equal to L as x tends to a. Good? Understood? Now come to the existence of the limit. So when your LHL, left hand limit and right hand limit, your LHL means left hand limit, RHL means right hand limit. When both LHL and RHL is both are equal, then your limit exists. So LHL, how it is defined? When what is LHL? First know that what is LHL. So in case of limit, we approaches your a, we approaches A, your x approaches to A. We write x approaches to A. So we can approach from the left hand side, we can approach from the right hand side. Okay, so when we approach A from your left hand side, then it is called left hand limit. And when we approach to A from the right hand side, we call it as RHL, that means right hand limit. And when we approach from A, means to A from left hand side, it is called left hand limit. Okay, so so in the notation we write limit of f of x as x tends to A minus, and this minus is not for difference, it is the notation because of we approach A from the left hand side. So A minus, always remember that A minus means it is less than A, it is less than A. Okay, so less than A means from the left hand side we approaches to A. So A minus means less than A. Similarly, RHL, in case of RHL we write limit x tends to A plus, and this A plus means we approaches to A from your right hand side, and A plus means it is greater than A. Okay, so A plus means what? Greater than A. Greater than A. Okay, so that's why we write here f of A minus h, because it is less than A, and in case of right hand limit we write f of A plus h as h tends to 0 plus. Okay, so you can write RHL like this, or if you introduce h, then we can write also this. F of A plus h means x is towards A, and from right hand side we approach, so your A plus means A greater than A, so we write A plus h as h tends to 0 plus. Understood? Now, for the existence of the limit, your left hand side means your LHL and your RHL. LHL and your RHL should be equal, and if the values of LHL and RHL is equal to L, then your limit of fx is equal to L. So for the existence of limit, your LHL should be equal to RHL. If this LHL is equal to RHL, then your limit exists. Limit exists. And this, what is the value of the limit? The value of limit is equal to L. If LHL is equal to L, LHL is equal to RHL, and that is equal to L, then your value of the limit is also L. Okay, so we have to remember that for the existence of limit, LHL should be equal to RHL. So for LHL, we will calculate limit x tends to A minus. For LHL, we will calculate limit x tends to A minus fx. And for RHL, this is for RHL, we will calculate limit x tends to A plus fx. Okay, this is for LHL, this is for RHL. Okay, come to some example. So here you can check the example for the existence of a function. So a function is given by fx is equal to x square when x less than 2, 3x minus 2 when x greater than or equal to 2. This is how function is defined. Now we have to check the existence of the limit of fx at x equal to 2. At x equal to 2. So for at 2 we have to check. So what we have to find? Your LHL is equal to RHL. So now to calculate LHL, so at 2 means limit x tends to 2 of fx. We have to check this whether it is defined or whether it exists or not. So for this existence, we have to find LHL. LHL. So LHL means limit x tends to 2 minus fx. Okay, so now that is equal to, since it is 2 minus, that means 2 minus, already I have told that 2 minus means it is less than 2. So for less than 2, how it is defined? Fx equal to x square. For less than 2, fx equal to x square. So limit x tends to 2 minus fx, in place of fx put x square. Okay, so what we will get? LHL is equal to limit x tends to 2 minus x square. So x square means, just put in place of x, it is 2 square is equal to, means it is approximately equal to, nearly equal to 4, because it is just less than 2. So in place of x just put 2. So 2 square is equal to, in place of x just put 2, so it will be 2 square is equal to 4. LHL is equal to 4. Now for the right hand side, right hand limit RHL, that is equal to limit x tends to 2 plus fx. X tends to 2 plus fx. Now what is fx here? Limit x tends to 2 plus. So what is fx? So when 2 plus means what? It is greater than 2. 2 plus means greater than 2. So for greater than 2, function is defined as 3x minus 2. When x greater than 2, fx is 3x minus 2. So that's why your limit will be what? Limit x tends to 2 plus 3x minus 2, and that is equal to 3 into 2 minus 2, and this is 6 minus 2 equal to 4. Now you can say that LHL is equal to RHL, and that's why limit exists. And what is the value of limit? What is the value of limit? Both are equal to 4. Both are equal to 4. So limit of fx as x tends to 2 is equal to 4. So this is how we have to check the limit or existence of limit at a point. Now come to the second example here. This is a second example. How it is defined? Fx. When x less than 2, fx equal to x square. Same function. When fx, your fx equal to x plus 3, when x greater than equal to 2. So when just it is different from the previous example, when x greater than equal to 2. Now if you want to calculate LHL, so LHL will be limit, same procedure, limit x tends to 2 minus. So when it is 2 minus means, just remember that it is less than 2, and when it is less than 2, function is defined by x square. So put x square in place of fx, so it will be 2 square, and that is equal to 4. But in case of RHL, that means limit x tends to 2 plus, and 2 plus means x your greater than 2, x is your greater than 2, and greater than 2, for greater than 2, function is defined as x plus 3. What is defined? Function is defined as x plus 3. So in place of x, put x plus 3. So it is equal to 2 plus 3, and that is equal to 5. Okay, so what we got here? In place of LHL is equal to 4, in place of RHL it is 5. So LHL is not equal to RHL. That's why your function limit does not exist at x equal to 2. Okay, so limit does not exist at x equal to So in this way you can check for the existence of different types of limit of the functions. Okay, now come to the next slide, that is which contain your basic formula. These are some basic formula we have to remember so that we can easily find the limit. Okay, so what are the formula? First, limit of some constant when x approaches to a, but here function is a constant function. Limit x tends to a is equal means of function c. In place of fx, it is a constant. So x tends to a, there is no x here. In function, there is no x. It is a constant only. It is a constant only. So there is no effect of limit. No effect of limit means, so your result is always c. Okay, so your limit will not affect the constant function c. Now limit x tends to a, second formula is limit x tends to a, in place of x put a and that will be equal to a. It is very easy. Now limit of fx plus gx, then you can separately find the limit of fx as x tends to a plus limit of gx as x tends to a. Similarly for minus case, fx minus gx as x tends to a, you can separately find the limit and it will be equal to limit of fx as x tends to a minus limit of gx as x tends to a. Next come to the other formulas, and in case of into product of two functions, and we have to find limit of product of two function fx into gx. So in case of fx into gx, same thing, we can write limit of fx into limit of gx, and for division case it is limit of fx divided by limit of gx. And whether k is a constant which is multiplied with the fx, then you can take out k and then is limit into fx. Then next formula is limit x tends to fx to the power n. So just keep like this with the power n. Keep the power n as it is and just take the limit of fx in the bracket. Okay, the power will be remain same, but you should take the limit of fx in between the bracket, and it will be the power limit of fx power n. Here it was limit of fx as x tends to a, means limit of fx to the power n, and that will be equal to limit of fx whole power n. Similarly, if it is limit x tends to a of what function is what nth root of fx, so you can write it will be equal to nth root of n. You just find limit of fx, then it will be equal to limit of fx then nth root. Okay. Now next formula, you just remember this, these are the formula, and in this case just remember this limit of sin x by x as x tends to 0, it is equal to 1, limit of tan x by x as x tends to 0, it is equal to 1 tan x by x. And you can derive these formulas from these two formula. Just remember these two formula from this slide. You just remember these two formula. Other formula you can derive. Okay, like how you can derive, just see here. Suppose we have to calculate limit x tends to 0 sin ax by ax, sin ax by ax. Now that is equal to, just see the formula here, limit sin x by x, x tends to 0. Here x, here x, here is also x. In this formula, in the left hand side, x tends to 0, sin x, x. So here it is ax, but here x only, x tends to 0. So we know that when x tends to 0, your ax is also tends to 0. Now this limit can be written as, this limit we can write limit ax tends to 0, sin ax by x. Now take this ax as y. So if we put x as y, what we will get? limit y tends to 0 sin y by y. So now compare with the formula. Limit y tends to 0 sin y by y, and that will be equal to 1. That will be equal to 1. Okay. Similarly, for this formula, formula number 5, also you can use, just remember these two formula, all then you can derive all these formula. Okay, you have to remember these two formula only. So for the fifth formula, you can take limit x tends to 0 sin x by bx. Now we should check here, if it is x, here it must be x, here it must be x, but here it is sin ax, here it is x only, so it should be same, so that we can apply the formula x bx x, these are must same. So for this, we can write limit x tends to 0 sin ax by ax, that multiply x and multiply and divide x, and we have bx here. Before we have bx in the denominator. So now you can check here limit, since we know that limit of f into g, limit of f into g. So limit of f into limit of g. So limit x tends to 0 sin x by x, then limit x tends to 0 ax by bx. Okay, and that is equal to limit of sin x by x, we know that this is equal to 1 into, and this portion you can take here, x cancel, a by b is constant, and there is no effect of limit on this constant, so it will be a by b, so result will be a by b. Result will be a by b. So this is how we can evaluate this type of question. Now come to next slide. There are some other formula. We have to remember that limit of e to the power x minus 1 divided by x is equal to 1. Limit of ln 1 plus x by x equal to 1. Just note down this formula, we have to remember. Now limit of 1 plus x whole to the power 1 by x as x tends to 0 equal to e. Limit of 1 plus 1 by x whole to the power x as x tends to infinity is equal to e. Limit of only marked formula we have to remember. Otherwise, other formula we can derive from this marked formula. Just we are marking. I am marking the formula what we have to remember. Okay. This is 1 by ln 10, because log 1 plus, here you just check limit x tends to number 14 formula. Number 14 formula you can write limit x tends to 0 log 1 plus x. If base is a divided by x, it will be 1 by ln a. Okay, here it is written ln 10 means the base is 10. If it is base 10, then it is 1 by ln 10. If base is a, then it is 1 by ln a. Okay. Now another formulas are another some limit x tends to 0 sin inverse x and tan inverse x by x, sin inverse x by x, both are equal to 1. And another important formula is what? This limit x tends to a, x to the power n, a to the power n divided by x minus a is equal to n into a to the power n minus 1. I think we can give some example here. Limit x tends to 2, x to the power 4 minus a to the power 4. A means here it is 2, x to the power 4, 2 to the power 4 divided by x minus 2. So in this case, what is the value of this limit? Just put this formula. It is what? A here, a is 2. check here, a equal to 2, and what is n here? N equal to 4. N equal to 4, a equal to 2. So direct formula, you can apply the direct formula. Formula is what? 4, a means 2, n minus 1 mane 4 minus 1. So that is equal to 4 into 2q, 4 into 2 to the power 3. So it is 4 into 8 and 32. The result is 32. Okay, this is how we can apply this formula. Okay, so only remember the marked formulae. Okay, next, come to the next slide. These are the indeterminate form, that 0 by 0, infinity by infinity, 0 by into infinity, infinity minus infinity. So 1, 2, 3, 4, 5, 6, 7. So these are 7 indeterminate forms we can find in means at the time of uh, solving of the limit, and these are the indeterminate form, and we solve this type of indeterminate forms using L'Hospital rule. Using L'Hospital rule, we solve this type of indeterminate forms. So what is L'Hospital rule? L'Hospital rule means, if we take limit of fx as x tends to a equal to 0, limit of gx is also 0, or limit of fx equal to infinity, or in limit of gx equal to infinity, it means it is 0 by 0 form or infinity by infinity form. Then what will be the value of limit of fx by gx as x tends to a? That will be equal to limit of f dash by g dash as x tends to a. That means you just differentiate f and differentiate g separately, then take limit as x tends to a. Then take limit as x tends to a. Okay, if suppose f dash always means, again we got limit of f dash by g dash is equal to 0 by 0 form. Then again we have to differentiate. That means the limit will be equal to limit h tends to a f double dash divided by g double dash. Separately differentiate the numerator, difference the denominator, then take limit as x tends to a. If it gives some finite value, then it's okay. Otherwise, again you just check whether it is 0 by 0 or it gives some finite value. If it is 0 by 0, then go for the next derivative, and if it is not 0 by 0 and give a finite limit, then we are over. We will get the result. Okay, so this is how we can find the solutions of indeterminate forms. This is the L'Hospital rule. Okay, so you can give some example here. That is, suppose limit, we have to calculate a limit x tends to 0. Suppose it is 2x divided by 1 minus x square, divided by 1 minus, not, it is 0 by 1. Suppose it is x tends to, suppose, no, it will be 0. So suppose question is 1 minus x. Suppose limit, question is, suppose limit x tends to 1 or x tends to 2, suppose x tends to 2, x square minus 2 square divided by x minus 2. So here you can check, if you put 2, the numerator will be 0, divided by 2 minus 2, it is also 0. So it is 0 by 0 form. So we can approach using L'Hospital rule. So using L'Hospital rule, we can get what? It will be limit x tends to 2 and differentiate this and this separately. So if you differentiate the derivative, means differentiate the numerator, it will be 2x, and you can find the derivative of denominator, it will be equal to 1. Now come to the limit. If you put the limit, then it will be 2 into 2 and 2 into 2 divided by 1, and that is equal to 4. Okay, so this is how we can apply L'Hospital rule to find out the indeterminate forms, the solution of the indeterminate forms. Okay, now come to the next slide. So these are some techniques to find out the limit. Factorization, you can take the rationalization, you can take the substitution. So these are some techniques to find out the limit. Okay, now come to the sandwich theorem. What is sandwich theorem? If fx less than equal to gx less than equal to hx, that means there is a function gx in between fx and hx, then if limit of fx equal to L, limit of h is equal to L, then the limit of g also L. That means like a sandwich, your fx value and hx value, this the limit of fx and gx is equal to L. That means the middle function, that means which is in between fx and hx, and this limit is also will be equal to L. If limit of f equal to L, limit of h equal to N, then limit of g is also equal to L. So this sandwich theorem can be applied to find out this solution of limit x square of into sine 1 by x is equal to 0. How it is? How you can calculate? If it is to find out limit, we have to find limit x tends to 0, x square sine 1 by x. So how to calculate this? We know that the value of sine is always in between 1 and minus 1. Sine of 1 by x, the value of this is always in between 1 and minus 1. You know that. So now multiply x square throughout the inequality. Just multiply x square and x square. If you multiply x square, then take x tends to 0. Then take its limit. Then take limit. If you take the limit of x square as x tends to 0, as x tends to 0, limit of x square as x tends to 0, so this will be 0, this will be 0, so the middle portion, limit of this middle portion is also 0. Okay, using your sandwich or squeeze theorem. Understood? We'll do many more problems in the next class. So in this class only I cover all the theories of the limit and some problems regarding this formulae, or relating this formulae and relating these theorems. Now come to limit at infinity, and this type of problem we can solve like this. Limit x tends to infinity, 3x square of this. You just take the highest power of x common. Okay, what is the procedure to find out this solution? You just take the highest power of x square common. Limit x tends to infinity. What is the highest power of x here? X square. So take x square common. So it will be 3 plus 2 by x plus 1 by x square. Similarly, in denominator, what is the highest power? X square. So take it common. So 5 plus 4 by x square. Okay, so x square cancel and take x tends to infinity, and we know that limit 1 by x as x tends to infinity is equal to 0. So that's why, and this is 0, this is 0 and 0, only we will find 3 by 5. Okay, so this type of problem can be solved using this procedure. And this is also another formula to find limit of e to the power 2x minus 1 by x. So this is another formula. We know that. What is the formula? We got in the list. Limit x tends to 0, e to the power x minus 1 by x is equal to 1 here. We know that. This is the formula. But here it is 2x only. In this case, it is e to the power 2x. So just remember that if it is x, here it is x, here it is x. So in three places x must be there. But here in case x is here, but here it is 2x. So make all the x as 2x. Okay, so we can make this as limit x tends to 2x tends to 0, e to the power 2x minus 1 divided by 2x and multiply 2. Okay, so and this limit we know that according to the formula this limit is equal to 1 and 2 is the constant, so 1 into 2 is equal to 2. So the answer is 2. Okay, so we have to adjust the functions as per our formula. Okay, as per our formula we have to adjust the function so that we can apply the formula. Next, this type of formula this is a logarithm formula. This is a logarithm formula. What is the formula? It is also in our list. Limit x tends to 0, ln 1 plus x by x is equal to 1. But here 5x is there. 5x is there. So we have to make all the x as 5x. So you can adjust like this. Limit 5x tends to 0, ln 1 plus 5x divided by 5x, and we cannot make 5 like this, so we have to multiply 5. Now for this limit, that will be equal to 1 and 5 is constant, so 1 into 5 is equal to 5. So this type of formula we can apply adjusting the problem. Okay, so we will meet in the next classes with some more problems of limits and the other topic of calculus like derivative, integration. Okay, so subscribe the channel and read all the formula, all the theories of limit, so that we can easily understand and easily solve the problem. Thank you.